There are lots of methods for drawing Lewis structures. Ultimately, as long as you're consistently getting the right structure, I'm fine with whatever method you choose. If, however, you find that you're not getting the right structures, especially when multiple bonds are involved, then this method almost always gets you to the right place. Whatever method you choose, please, 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 please always start with a valence electron count. Your structure can have no more and no less electrons than indicated by this count of valence electrons. I have drawn approximately 147,263 Lewis structures in the past 15 years. I still do a valence electron count for every new structure. This process that I'm going to describe in this video is for molecules with a single central atom, and again starts with a valence electron count. After that, we need to identify the central atom, and we're going to do that based on electronegativity. The central atom typically is the least electronegative atom, the primary exception being when hydrogen is present. Hydrogen never is the central atom because it forms only one bond. Another way to identify the central atom is to look for the loner, the element of which there is only one atom when there's more than one of the other types of atoms. After the valence electron count and determining the central atom, connect each other atom in the structure, or in the formula, to the central atom with a single bond. Subtract 2 electrons per bond from your valence electron count. Next, distribute the remaining electrons in pairs to the atoms. Though this slide says to complete the octet of one atom before proceeding to the next, I actually prefer to do this symmetrically. In other words, put one lone pair on a non-central atom, then one lone pair on the next non-central atom, etc., until each non-central atom has one lone pair. Then repeat with a second lone pair of electrons on each non-central atom until you run out of electrons. What I really mean by that is subtract 2 electrons from the valence electron count for each lone pair that you add. Next, count. Again. Does each atom in the structure have a complete octet, or a duplet in the case of hydrogen? How many electrons total are in this structure? How does that number compare to your valence electron count? Is it exactly the same? Is it greater than your valence electron count? Or is it less than your valence electron count? I'll go ahead and say that if you have more electrons in your structure than the valence electron count, then something is wrong. The only acceptable options here are that you have exactly the same number of electrons as in your valence electron count, or your structure contains less. In other words, you have leftovers. Again, if all atoms have a complete octet and your structure has the same number of electrons as your valence electron count, then you're finished. You're just done. If any atoms in the structure have incomplete octets and you have run out of electrons based on your valence electron count, then you'll need to move lone pairs off of non-central atoms and make them double or triple bonds to the central atom. If all of the atoms have a complete octet, but your structure has fewer electrons than your valence count, then put any of those leftover electrons on the central atom. Now, that was a lot of information, and it may not seem like it makes much sense now, so what we're going to do in the next 2 videos is look at specific examples. Then we're going to work lots and lots and lots of examples in class.